this question, we have a ball rotating around a rod. The rod will be rotating in this direction, and it's attached by two cables. We'll call the first cable has a value of force tension 1, and the second cable we'll say has a value of force tension 2. Our job in this question will be to find the value of both of those. So this ball is attached by two strings to this rod, and the whole rod is, of course, rotating. So we do know that there will be centripetal acceleration. We'll need to know the radius then. So the radius would be from here out to where the ball is. And we have a 1 meter hypotenuse, and here's our angle. So that's the opposite side. So the radius then is going to equal 1.0 times the sine of 44. The radius comes out to be 0.695 meters. Okay, now we can find the value of the centripetal force acting on this. So force centripetal would equal 2.0 multiplied by the velocity, 4.2 squared, divided by the radius of 0.695. Force centripetal then has a value of 50.8 newtons. And we also know that the gravity force on this 2 kilogram ball will come into play, so we're going to find the force of gravity. So the force of gravity is equal to 2.0 times 9.8, which equals 19.6 newtons. Again, we may be tempted to use the horizontal circle pendulum for this question, but we can't because there is a string attached from the bottom. So we have to do it by the sum of the forces in the x direction and sum of the forces in the y direction. So let's label the diagram. So we have a force tension going upwards on this cable. Let's break it into x and y's. This side will be force tension 1 in the y pointing upwards. And this will be force tension 1 in the x pointing to the left because our direction is this way. Let's do likewise to the bottom vector. This will be pointing downwards because the force tension will be pointing in this direction. So this would be force tension 2 in the y. And this one here will be force tension 2 in the x. Let's solve the sum of the forces in the y direction first. So sum of the forces in the y direction we know will equal 0. That'll equal force tension 1 in the y minus force tension 2 in the y minus the force of gravity. The force of gravity is just straight down from the ball. Now the sum of the forces in the x direction are different. That will equal the force centripetal. Let's take a look at that. Force centripetal will be pointing this way, so that'll be a minus sign because force centripetal is pointing to the left. That's going to equal a minus force tension 1 in the x, pointing in that direction, and then minus force tension 2 in the x, because that one's also pointing in this direction. Of course, we can factor out a -1 there, and then the force centripetal will equal force tension 1 in the x plus force tension 2 in the x. Okay, in our next video, we'll solve this expression for force tension 2 and force tension 1.